The reason why it changes concentration is because the solvent volume changes. We're going to be adding water to these solutions and causing them to be diluted. Note we saw that above in the osmosis figure that the number of solute particles didn't change when the water moved and lowered the concentration. Solution dilutions are commonly carried out in lab and clinical settings. So the main formula you want to use is this M1V1 equals M2V2. Capital M is molarity, capital V is volume. Molarity is usually expressed in moles per liter, and volume is almost always expressed in liters. But volume can be expressed in any unit you want. As long as V1 and V2 are the same unit, you can use milliliters as well. But what the subscript 1 usually is your initial condition, subscript 2 is your final condition. Another way to write number 1 would be, you would call that the concentrated solution. 2 might be the diluted solution. We use a subscript C for these or a subscript D for those. But how does this work? Well, when you do a dilution, what you usually do is what's called serial dilution, S-E-R-I-A-L. You take a stock solution, which you know the concentration of, and we'll call that molarity M sub 1. You'll take a little bit of that stock solution, put in, let's say you put it in a test tube, and then you add some water to it. Then you diluted that. M2 now will be less than the molarity of M1. And then if you want to make more dilute solutions, what you usually do is you take a small piece of this and put it in a new test tube. The other way you could do it is you could just take a smaller piece of this and put it in this test tube. But the normal way to make a series of diluted solutions from a stock is to take a certain amount of the stock solution, put it into the first test tube, add water. So you dilute this solution, M2 is less than M1. Then you take a small piece of this solution and put it in a new test tube, add some more water, create a new solution, M sub 3, which now has a molarity less than M2. Take a small piece out of this and dilute it with water. You can see the color of the yellow is getting lighter and lighter because it's getting more and more diluted. M4 would then be less concentrated than M3, which would be less concentrated than M2, etc. But in every case, if you're trying to calculate M2, M3, M4, you can always use this formula. And why does it work? It works because M times V means moles. Look at how the units work. M is moles per liter, and V is liters. When you multiply moles per liter times liters, the liters cancel and you get moles. So really all this formula is saying is the amount of moles I removed in the original step out of the stock solution, the amount of moles in all these, between these two, for instance, is the same. That's why I have the equal sign. The moles before equals moles after. Moles of solute doesn't change during a dilution. That is key to remember. The concentrated solution is called the stock solution. Volumes and molarities of the stock solution and diluted solution are mathematically related by that formula that I have up here. So let's do a few examples. The best way to illustrate this is through many examples. So for instance, let's say you have a 5.0 molar stock solution of glucose, and you want to make 50 milliliters, 2 sig figs, of a solution that's 0.25 molar. How do you do that? What volume of the stock solution, how much of this do you need to be transferred? Well, you figure out how many moles are present in the original, how many moles of stock solution do you need? So as long as you label everything correctly using this notation, you can't go wrong. So in this case, my M1, my initial concentration is 5.0 molar, and you have to pay attention to the question. They want to know what volume of the stock solution needs to be transferred. So they want to know what volume of the original solution, which is subscript 1. So you're actually solving for V sub 1. That's why I have the question mark there. You know the characteristics, you know the properties of the solution you're diluting, this M sub 2 situation. It says you want to make 50 milliliters, that's M sub 2, that's V2, of your diluted solution that is 0.25 molar. So you see the diluted concentration is less than the concentrated solution. So again, that's what we're talking about here. This is our M1. This is our M2. M1's greater than M2. So you just start with this formula, and you solve it for the unknown variable, a lot like what you were doing for the gas law problems in your most recent homework. You have an equation, you plug everything in, you put the unknown variable on one side, you solve, you put all the known things on the other side, and you plug in the numbers and solve. So M2 is 0.25 molar. My diluted concentration, 50 mils, is my volume of the diluted solution over the original concentration. Notice how the units cancel out. Molarity on top cancels with molarity on the bottom, and I'm left with milliliters. That's how you know you did the problem right. The units cancel, and the unit that you're left with is the answer to the question. What volume is needed? That's milliliters. You could have done it in liters if you wanted to, but you don't have to convert these to liters. Here's another problem. You transfer 25 milliliters of a 5 molar stock solution to a volumetric flask and add water to give a total volume of 100 milliliters. What's the new molarity? So again, you have to really read these carefully. But if you do, you shouldn't be any trouble setting up your known information. So what's your known information? My initial volume was 25 mils of my initial concentrated solution, so that's M sub 1, V sub 1, right here. I want to know what's the new molarity, M sub 2, if I have a total volume of 100 milliliters here. So again, the same problem. Solve for M2, put everything on the other side, move V2 to the other side, I'd get my initial molarity times my piece of that stuff over 100. So if you look at this, it's just like you're saying, take the initial concentration stock solution and dilute it 4 times. You're cutting it concentration by 4. You take 25 mils of some stock solution, add water to give a total volume of 100. So you're just you're diluting it by a factor of 4. We call that a dilution factor of 4. That's why the answer is 1.3. 1.3 is essentially 1/4 of 5 if you round to 2 sig figs. It's the number 5 times the ratio of 1 over 4, which in this case is 25 over 100. So dilution problems aren't necessarily that difficult. It's just ratios, but you have to read the questions carefully to understand what goes where. And again, I'm going to do some more of those in a little bit. I'm at 18 minutes here. I'm going to end this video right here and splice it together with the original video, and we'll continue on with the colligative properties in video number 2.